fields, what are these things? Obviously, you know about electric field and magnetic field. In vector algebra, what do we mean by a field? There can be two types of fields, a scalar field and a vector field. Say, if we have a scalar field phi, which is a function of x, y, and z, so we can say that phi depends on x, y, and z, and if it is not a constant function, if it is not a constant, then it will vary from point to point. So we can take an example. Say, inside the kitchen, the oven is burning. So the temperature will be different from point to point. It may be a function of time as well. But for the time being, we are not considering the time dependence of these things. For simplicity, we are saying that it is a function of x, y, and z. It can be a function of n number of variables. For the time being, we are considering it to be a function of x, y, and z. Okay. So the temperature can be a scalar field. It may vary from point to point. Even inside your room, the temperature varies from point to point. Likewise, there can be vector fields as well. Say electric field. Electric field, E vector, it is a vector field. The direction and the value will vary from point to point. Say we have a charge distribution. So the electric field will point at different directions, may point at different directions, and the magnitude of the electric field may be different from point to point. So basically it is a function of x, y, and z again. So it is a vector field. So now what is a directional derivative? What do we mean by a directional derivative? Say we have a scalar field phi, which is a function of x, y, and z, and we want to find out the directional derivative. What do we mean by that? Say there are 2 points, x0, y0, z0, and x, y, and z. So it is the starting point, and it can be an arbitrary point anywhere in the space. So once we have chosen x, y, and z, and x0, y0, z0, we can always find out a vector pointing from x0, y0, z0 in the direction of x, y, and z. So it is a vector. We can call it a vector or whatever we like. And if we can write it as a vector quantity, we can always find out an unit vector in that direction. So the unit vector in the direction is u vector. Say, so u vector is ai cap plus bj cap plus ck cap. It is a unit vector, so the magnitude of u vector, mod u vector, should be 1. So what is the distance from x0, y0, z0 to xyz? We call that s. So that vector which points from x0, y0, z0 towards xyz is su vector, because u vector is the unit vector in that direction and s is the magnitude of that line. It is a distance. So if we multiply the unit vector with the magnitude, it is basically a scalar multiplication of a vector. So it will give us the vector in that direction. What is our goal here? We are saying that we are talking about scalar fields. Scalar fields vary from point to point. And if we want to know what is the rate of change of that particular field in a given direction, if you take the instance of the temperature as a scalar field, we may want to know what is the rate of change of temperature in a given direction. What is the rate of change of temperature in the direction of the oven from your location? Or what is the change of rate of change of temperature in the direction of the window or the door, right? So we may want to know that. So if it is a function of x, y, and z, it is an exact differential d phi. So the differential change of phi, the scalar field, can be represented in this way: del phi del x dx, del phi del y dy, plus del phi del z dz. Now we want to know what is the rate of change of phi with s. So that is d phi ds. Now we are calling the d phi ds as the directional derivative. And why do we do that? As d phi is this, So d phi ds can be written in this way: del phi del x dx ds plus del phi del y dy ds plus del phi del z dz ds. We can write it in this fashion. তাই তো? এবার what is dx ds dy ds and dz ds? আমরা বলেছিলাম এর আগে যে this vector su vector, where u vector is a unit vector in that particular direction and s is the distance, s is the length of that vector. It is a vector pointing from x naught y naught z naught towards x y z. So x is basically x naught plus a into s, y is y naught plus b into s, and z is equal to z naught plus c into s. Isn't that? Because if we multiply u vector with s, so su vector is basically s into a I cap plus s into b j cap plus s into c k cap, right? A into s, b into s, and c into s. So you're starting from that point. So what is the increment of x naught? If we go from x naught to x, that is x naught plus a into s. So ax is basically x naught plus a into s. Likewise, what is the increment of the y coordinate? So it is starting from y naught and it is going to b into s. So y is y naught plus b into s. Likewise, z is equal to z naught plus c into s. So x here, x naught, y naught, and z naught is the coordinates of the starting point. So these are constants. It is a unit vector, u vector. A, b, and c, these are also constants. So basically x, y, and z, these are functions of s. X is a function of s, y is a function of s, z is a function of s. S is basically the parameter here. So if we differentiate x with respect to s, what do we have? Dx ds is only a, because this is a constant term. If we differentiate that, it goes to 0. So you're left with only a. So dx ds is a. This is a. This thing, this term. Likewise, dy ds is b. Dz ds for this particular example is c. So d phi ds, this directional derivative, is a into del phi del x plus b into del phi del y, c into del phi del z. Let us define a particular quantity, gradient of phi. So this gradient is a vector operator. So gradient of phi is del phi del x I cap.
স্যার ওই নামটা কি বললেন আরেকবার বলুন?
এটার নামটা
ডেল অপারেটরের নামটা কি বললেন? হ্যাঁ হ্যাঁ হ্যাঁ, ডেল অপারেটরের নামটা কি বললেন?
এটার নামটা হচ্ছে ন্যাবলা। So this del operator is basically this. It is a vector operator. Sorry. Del del x I cap plus del del y j cap plus del del z k cap. So for the time being, we are talking about this del operator. So this operator is operating on phi, and we are calling this as grad phi, gradient of phi, gradient of that scalar function phi, which is del phi del x I cap plus del phi del y j cap plus del phi del z k cap. So what is the big deal? Look at this expression. D phi ds is a into del phi del x plus b into del phi del y plus c into del phi del z. So we can write the directional derivative as gradient of phi dot u vector, where u vector is the unit vector in that particular direction. So if we want to know the directional derivative of a scalar field at a particular point, so what do we have to do? First of all, say you are given the scalar field as a function of x, y, and z, and you are asked to find out the directional derivative of this in the direction of a given vector a vector at a particular point x naught, y naught, z naught. So phi is given, it is a scalar field. এবার তোমাকে একটা directional derivative বার করতে হবে in the direction of a vector, and you are given a particular direction a vector. Now you are asked to find out the directional derivative, but we need to know the starting point. Where do we want to find out the directional derivative? এই ডিরেকশনেই আমার এই rate of change of phi may be different from point to point. তার মানে আমার একটা পার্টিকুলার পয়েন্টে জানা দরকার, সেই পয়েন্টটা ধরো দেওয়া আছে, ধরা যাক পয়েন্টটা হচ্ছে 1,2,3. So how to do that? First of all আমায় কি বার করতে হবে? আমি যদি ডিরেকশনাল ডেরিভেটিভের আলটিমেটলি ডেফিনিশনটার দিকে যাই বা এক্সপ্রেশনটার দিকে যাই, d phi ds is gradient of phi dot u vector. U vector is the unit vector in the direction of this, যে ডিরেকশনে আমি ডিরেকশনাল ডেরিভেটিভ বার করতে বলেছি সেই ডিরেকশনে. So we need to find out the unit vector in the direction of a vector. So we have to divide a vector with mod of a vector or the magnitude of a vector. So what is the magnitude of a vector in this particular case?
5. 5.
ঠিক আছে, তার মানে a cap হচ্ছে 3/5 of 3/5 I cap, তোমার খাতা লিখে গেল, প্লাস 4/5 k cap এই পার্টিকুলার কেসে, এটা হচ্ছে a cap, সরি। আচ্ছা এইবার আমার কি বার করতে হবে? We have to find out gradient of phi. So what is gradient of phi here? Gradient of phi is del phi del x I cap. তার মানে এইটাকে যদি আমি এই এক্সপ্রেশনটাকে if we differentiate this expression with respect to x partially, what do we get? এই পার্টটা 0 হবে, এই পার্টটাকে যদি ডিফারেন্সিয়েট করি with respect to x, partially differentiate করা মানে কি other variables should be held constant while differentiating with respect to a particular variable. So here we are differentiating with respect to x, so we are left with 2xy. 2xy এটা 0, তার মানে del phi del x is 2xy. So you have del phi del x I cap, so 2xy I cap. এবার del phi del y কত?
X square.
Right, so x squared j cap. এবার del phi del z কত?
3z
square.
আচ্ছা, রাইট, পেয়ে গেলাম আমরা। So it is the value of gradient of phi. এবার gradient of phi তো x y z এর ন্যাচারালি বুঝতে পারছো যে বিভিন্ন দিকে x y z এর বিভিন্ন ভ্যালুর জন্য বিভিন্ন রকম হবে, কিন্তু আমাদের কোয়েশ্চেনটা কি? we have to find out the directional derivative at this particular point 1, 2, 3. So gradient of phi at this particular point, what is that? Gradient of phi at 1, 2, 3 কত হবে? 1, 2, 3 কত হবে?
Sir, 4 I cap plus j cap plus 27 k cap.
4 I cap plus j cap.
27 k cap.
So we know gradient of phi at that particular point, and we know a cap. So grad phi dot a cap will give us the directional derivative at that particular point. 3/5 into 4, 12 5 আছে এখানে, প্লাস কত?
Sir, it's 108/5.
Sorry sir, আমি j cap লিখে দিয়েছি।
হ্যাঁ 120/5, 24 তাই তো?
24 আসবে 24, yes sir.
So that is how you find out the directional derivative.